Okay, so for today we start with chapter 3. Tajuk chapter ni sebenarnya adalah electric current and direct current, AC and DC circuits. Okay, so this chapter consists of 9 subtopic. Seems a lot, tapi sebenarnya tak. Dia for each subtopic tu pendek-pendek. In fact today, hopefully we can cover up until subtopic 4. So I plan to cover sampai 4 lah. What we're going to do today, kita akan go with the theoretical part sampai habis, and then after that hopefully we can try to do some of the tutorial questions related to the subtopic ni. Okay, for the first subtopic is 3.1 electrical conduction. Okay, there's few things that you guys need to be aware. I mean, this one is obvious lah. You have V, R and I. V is the voltage, R is the resistance, and I is the current. And voltage, the unit is V, resistance is ohm, and the current is ampere. So I think most of theoretical part in this chapter actually you already know. Just a refresh, ingat balik, study balik. Okay, so I think in previous chapter when I discussed about capacitor, I already show you the formula for current. I is equals to dq over dt. Okay, that particular formula yang belah kanan ni actually represent current at that particular time. We call that one as instantaneous currents lah. But normally they will ask you to calculate the average current. So normally you just use I equals to Q over T. And in exam biasa memang nampak obvious lah, whether to use this one ataupun that one. Dan markah formula pun tak ada, so biasanya betul je. Then the equation Q is equals to NE, where Q is the charge yang ada, N is numbers of electrons, and E is a constant values for electrons charge. So number of electrons, and E is your charge value. By the way, kamu dengar suara saya jelas ke? Tidak?
Jelas sir.
Ada breaking.
Tak ada lagi, okay, good. And ada lagi few things you guys need to know about this subtopic. Yang 3.1 ni is about microscopic model of current. Yes?
Dalam tu elektron ke sir?
Dalam tu electrons of current.
Interesting.
Okay, so before this, masa kita belajar semua ni, kita just tengok yang secara luaran. We talk about the circuits and we know that direction of current, direction of electrons ke mana. But then in detail, so kita akan tengok sikit lah. Dia jarang tanya pas dalam exam final sebab dia tak ada calculations. Tapi dia maybe boleh tanya dalam UPS or things like that. Okay. So if you looking over here, you can see that this circuit initially is disconnected. It's not a complete circuit, dia disconnected. So when it is disconnected, basically voltage ni dia tak main peranan pun. So there's no potential difference across here. Tak ada potential difference. So if we zoom in, kalau kita tengok dalam ni, this is a wire. So dalam wire tu basically saya besarkan dia jadi macam ni. Okay. So you know that wire is actually a conductor. Okay. So inside conductor, one of the key properties of conductor is that you have a free move electron. So electron tu boleh bebas pergi ke mana-mana macam highway lah. So these electrons, if there's no potential difference, it keeps on moving randomly and haphazardly. So maksudnya dia bergerak secara random, rawak dan tak ada direction lah. Kadang-kadang dia langgar dinding everything. So dia sentiasa bergerak. Okay. And once you connect the circuit, so this one becomes a closed circuit. So this one is what we call power supply. Jadi kita belajar pasal EMF. So let's say if you have EMF over here, EMF stand for electromotive force. So obviously it will create a force for the electron to move. Okay, and then it creates a potential difference across here. So kalau kita tengok direction of positive and negative terminal tu punya battery tu, so obviously this one all becomes positive and this one become negative. Okay, and then since yang ni semua zoom in punya diagram, so positive kat situ, negative kat situ lah. So you guys still remember tak direction of electric field daripada ke kanan ke kiri kalau case ini? Is it to the right or to the chapter 1
current
daripada dia sebenarnya ke kanan lah. So dia keluar daripada positive charge, dia masuk dekat negatif. So maksudnya dia keluar dekat positif, dia masuk dekat negatif. So this is the direction of electric field. Saya tukar colour dia sebab tak nak takut confuse dengan apa tu, direction of electron. Sekejap mana tadi. So this one is the direction of electric field. So if you guys still remember chapter 1, if you have point charge ataupun freely moved charge and then you have a constant electric field, charge tu dia akan pergi somewhere. Okay, so kalau elektron dia akan bergerak ke kiri ke kanan?
Elektron akan bergerak ke kiri.
Yes, dia akan bergerak ke kiri because of the electric field tu ke kanan. So dia akan move in opposite directions lah. Tapi in reality dia tak move straight lah. It's not like this, it move like this. Sebenarnya dia akan masih lagi zigzag, cuma in general it will try to move to the left. Okay, so it's not in general, dia more to on average dia bergerak ke kiri. So when I say on average, kita ada satu term, we call that one as V drift. Okay, drift velocity ni
DRIFT ke sir?
Drift velocity maksudnya dia drift to the left lah, dia bergerak ke kiri in general lah. So ini kira dia punya average velocity. So kita nampak elektron sebagai dia ke kiri lah, but in reality dia akan bergerak, dia still zigzag, cuma generally dia ke kiri. Okay, so because of that, all the electrons in the circuit dia akan move in that direction. So this would be your direction of electrons. So you can see that the electron actually moving daripada negative terminal of the battery and then dia pergi ke positive terminal of the battery. Itu one of the key findings lah from here. So direction of current, biasanya kita cakap kalau circuit is complete circuit and dia tanya dekat circuit tu direction of current, jawapan dia biasanya either clockwise or anti-clockwise. Okay, you cannot answer to the left or to the right because this one ada 4 direction kan. So in this case it would be anti-clockwise. Okay, direction of current, sorry, direction of electron. Confusing, tu dia pun salah, this one electron. Okay, on the other hand, direction of current dia sentiasa bergerak from positive terminal to negative terminal. This one because they already decided, macam saya cakap semalam lah, they decided that the direction of current sentiasa daripada positive terminal ke negative terminal. So in this case, direction of current would be clockwise. Untuk contoh saya lah. So far, any questions?
Tak ada sir, faham sir.
Okay, good. And for the first topic, the key parts for calculation is actually this formula, where I is equals to dq over dt. So you need to have a flow ataupun change in charge, then only you can have current. Okay, moving on to the next subtopic, which is 3.2, it's about Ohm's law and resistivity. So Ohm's law actually you already learned in school, where V is equals to IR. Ohm's law state yang V will always directly proportional to the current. Okay, V is directly proportional to the current as long as the temperature is constant. So maksudnya resistor tu constant lah, baru kamu akan ada V directly proportional to current. So this is one of the most common formula that you might use in this chapter, V equals to IR. So I think kalau sebut dia semua tahu kot, V equals to IR. So I want to draw the relation between V and I. On the graph, we will look something like this lah. It's a straight line, directly proportional, and any materials or any materials that obey this one, we call that one as ohmic conductor. Kalau ada conductor tu, behavior dia macam ni, V directly proportional to I, kita panggil material tu sebagai ohmic conductor. Kalau dia ada curve, tak ada dalam syllabus kamu kalau ada curve, itu maksudnya non-ohmic conductor. Masih tak ada dalam syllabus kamu, bukan kat chapter ni for sure lah, tak ada. And then unit for R, resistance tu tahap tahap resistance lah. Saya tak tahu nak tukar bahasa macam mana. So that one unit dia adalah ohm. Okay, resistance ni ada 4 faktor yang mempengaruhi dia. Number 1, the length. Number 2 is the area. Number 3 is the material type, and then the temperature. Resistance ni can maybe you can imagine, kalau saya suka imaginekan wire yang conductor tu sebagai highway, jalan lah. So kalau jalan tu panjang, okay, so maksudnya like this, if L is increase, R is increase. Jalan tu panjang kan, so lagi banyak resistance rintangan yang dihadapi. But then if you are talking about the area, okay, katakanlah jalan tu kalau dia lebar, wide punya jalan, then you expect that dia punya resistance to be less, bilangan kereta yang sama, so kurang resistance lah. So kalau wire tu tebal, kamu anggap dia sebagai kurang resistant. And then material types, jenis jalan lah kot. So material types ni dia akan effect satu quantity, nanti saya tunjuk. One of the main quantity yang dia effect adalah dia punya roh. Roh tu apa, jadi kita belajar. And the last part is about temperature. Itu pun kita akan pergi lebih detail soon. Okay, for now, any question?
Tak ada sir. Jelas.
Senang je ni. Jelas. Okay, and then you have another formula. Okay, we call this one as resistivity. Resistivity ni quantity tau. So resistivity basically depends on dua benda, dimension dengan type of material. Depends on okay, ni dimension lah. Kalau kamu tengok dia punya formulas ni, it depends on A dengan L. Tapi biasanya kalau dalam soalan ni, dia suruh cari R tau. So resistance, kalau saya ring R tu, dia akan jadi R equals to rho L over A. Ni biasanya rho ni, dia depends on material. Okay, yang dimension tu dia akan effect the resistance lah, tapi daripada formula ni kamu boleh nampak kot. Unit for rho is basically rho meter. Okay, because this one you have meter square, this one will be in meter, so they cancel out. So you left with ohm meter. So normally the resistivity depends on the material. So different material, you will have a different values for rho. Biasanya masukkan dalam formula je. And then make sure all the units in SI units lah. If you do that, then shouldn't be a problem. Kalau dikasih satu wire tu, dia kata conductor tu size dia macam ni. Kalau dia circular, so dia punya A dia tu pi r square lah. Kalau dia square, then dia punya A tu panjang darab sisi and so on. Length tu panjang dia. Mungkin saya boleh tunjuk correlation. So between R is directly proportional to the rho. Okay, R is directly proportional to the length, and R is inversely proportional to the A. Macam saya cerita tadi lah. Okay, ada soalan tak so far sebelum kita masuk 3.3?
Tadi sir.
Alright. Okay, for 3.3 is about variation of resistance with temperature. Okay, so maksudnya if the temperature changes, you will expect that the resistance of the conductor to change as well. So if let's say if we take this diagram, saya copy diagram ni, kamu rasalah apa yang berlaku bila temperature tu naik? What will happen when the temperature is increased naik?
Aktif.
Apa yang berlaku kat elektron tu?
Elektron tu akan more excited.
Okay, apa?
More excited.
Yes, more excited. Okay, very good. Okay, saya copy yang ni je. Bawa tu macam tak perlu. Mana tadi? 3.3. Okay. Okay, let's say if the temperature is increased, you will see that the electron will start to excite. So I can say that as temperature increase, electron excites. So bila electron excites, basically they have higher kinetic energy. So it's either move more ataupun move faster. So biasanya bila dia move more ataupun move faster, macam kamu lah kalau panas kamu dah tak ada diam kan. So what will happen is that they will increase in collision. So kalau increase in collision, kamu rasa adakah dia punya resistance increase ke decrease?
Increase.
Increase, very good. So macam kamu bawa kereta kan, kalau ada banyak accident kat depan tu, kereta tu makin slow, makin terharang. So resistance increase. Okay, so itu konsep perubahan temperature will affect the punya values of resistance. Okay, this is the formula. You can see that this formula is actually very similar to linear expansion. Kalau kamu ingat lah, linear expansion dulu kita ada L sama dengan L naught lepas tu 1 tambah alpha delta T. Sama je. Cuma sekarang ni instead of L, we have R. Okay. Okay. So, if I rearrange in terms of alpha, alpha here is equals to delta R over R naught over T. Delta T ni saya rearrange lah. Alpha ni maksudnya adalah temperature coefficient of resistivity for various material. Again, it depends on the material itself. So let's say for copper, maybe dia lagi cepat. Dia sebenarnya ada kaitan dengan apa tu? Minta maaf, saya tak nak cerita lebih-lebih. So alpha ni, it depends on the type of material. Contohnya for copper, you might have a specific value. For aluminium, you might have a different value. Okay, those value will be given lah. The formula for, the unit for alpha tu actually adalah per Celsius ataupun per Kelvin. Again, it doesn't really matter lah. Sebab yang ini adalah delta T. So delta T means you can use Kelvin, you can use Celsius as long as the unit is the same. Okay. Ini boleh dalam Kelvin, ini boleh dalam Celsius, again doesn't really matter. Okay. R there represent final temperature, final resistance. R naught is initial. Okay. The alpha is the coefficient. Delta T is basically the change in temperature. So delta T here would be equals to T final minus T initial. Okay, biasanya kita pakai T tolak T naught. T naught is the initial lah kalau untuk chapter ni. Okay, ada soalan about 3.3?
No sir.
Again, the formula is just this one. Satu je formula, so don't worry. And then 3.4. 3.4, you guys need to know about EMF, internal resistance, and potential difference. Okay, so there's a difference between EMF dengan terminal voltage. So EMF ni sebenarnya adalah, saya selalu cakap daripada last chapter dengan this chapter tadi pun saya ada cakap, EMF stand for electromotive force. Maksudnya force yang dihasilkan untuk tolak elektron. Okay, this is what it meant by electromotive force. Secara kalau kamu nak tengok daripada definition tu, kalau dia lagi besar, dia ikutlah dia nak tolak elektron tu. Okay. Okay, let's see if you have a battery. Katakan kamu ada battery 9 volts tu, yang macam square tu. Katakan dia adalah 9 volt. Okay, kalau dia tulis dekat situ 9 volt, that value is actually your epsilon, which is EMF lah. Okay, simbol tu ada nama dia epsilon. Dia panggil kalau dalam ayat itu adalah EMF. Dia akan sebut dalam soalan itu adalah EMF is equals to 9 volts. Okay, maksudnya itu yang ditulis daripada manufacturer, itu yang ditulis dekat label dia, itu yang sepatutnya diproduce. But then, if the battery is connected to the circuit, a complete circuit, and then you try to measure the punya voltage dekat sini, you will see that the values over here will be slightly less. So sedangkan yang ini basically just measured yang keluar daripada battery lah, tapi immediately dia ada less. So contohnya kamu kira kamu dapat V itu sama dengan 8.88 volt. This value is what we call V terminal. The one that we measured in a circuit, itu adalah terminal voltage. We represent that sebagai VT lah. Sebelum ni saya sebut sebagai V total ke apa kan. The correct term would be V terminal. So lepas ni kita pakai V terminal lah. Sebab sebelum ni kita tak cerita lagi, so saya tak cakap lah. So V terminal ni akan sentiasa less daripada epsilon, which is what is written on the labeling lah. So kenapa ada pengurangan ni? This is because due to the energy dissipation. Daripada mana datang energy dissipation tu? Is from the internal resistance of a battery. So any battery, tak kisahlah dia type apa, chemical ke, apa-apa types lah. dia mesti ada internal resistance. Kecil ke besar, dia still ada. So that's why you have a difference between epsilon dengan VT. Okay, so far you guys understand or not?
Understand?
Yes, sir.
Okay, okay, good, very good. Okay, now kalau saya nak tengok lebih lebih details lah. So ini example this is the battery. Okay, so if you want to represent inside a circuit, we basically draw something like this to indicate dia dalam satu benda. Yang ni kita tak lukis lah atas ni biasanya. Kita just a square brackets, tapi biasanya dotted line. Okay, and then kadang-kadang dia tak buat punya brackets tu, tapi dia label sebagai small r. So the small r here represent the internal resistance inside the battery. Okay, so this one adalah kamu punya EMF. Tapi bila kamu measure kat sini, dia dapat V terminal. Okay, and you can see from this one, V terminal ni is the one that we will get over here. Sebab dia apa ni? Macam ni kan? So dia duduk macam ni. V terminal samalah dengan VR dekat situ. In this case lah, untuk case yang saya tunjuk ni. And then kalau yang VR tu, itu biasa pakai simbol capital R. Okay, so I can deduce from this diagram alone, okay, VT ni yang kita baca kat luar ni sama dengan epsilon ni yang diberi oleh EMF, yang dibekalkan oleh manufacturer tu, contohnya tadi 9 volt tolak dengan drop of voltage across the internal resistance. Okay, if you can see this one, then shouldn't be a problem. So this is the concept lah. So from here I can write down IR. Sebab apa saya boleh kira IR? Sebab VT tadi saya cakap dia sama dengan VR. VR is equals to IR lah. So you only have satu current je. Current dia ada satu je lah sebab dia tak ada junction or anything else. Epsilon tu biar epsilon. VR ni dia jadi I, R kecil. Okay, and I can rearrange this one. Saya boleh bawa yang I tu ke kiri, lepas tu saya bawa semua ke kanan. Jadi IR plus IR. Okay, so far they make sense kan? If I factorize the I will get I R plus R. Okay, or I can write equation from this one. I can write epsilon equals to V terminal plus IR. Okay, so basically saya tukar yang ni lah, jadi V terminal balik and then tambah IR. So this two formula is very important. Okay, maybe selalu gunalah dekat dalam satu topik yang ini. Okay, masa bila nak guna yang atas, masa bila nak guna kat bawah, it depends on the information given. Saya rasa saya salah highlight. Ya, okay, ada soalan tak?
Tak ada sir.
Okay, kalau tak ada soalan, kita cuba buat soalan, and then we can see whether we really understand the topic or not. Okay, we start with question number 6. This one is tutorial question. Dia kata copper wire carries a current of 2 ampere for 20 seconds. Okay, cara dia, kamu boleh lukis circuit lah kalau kamu nak. Ini tak ada melibatkan circuit, so saya tak lukis. Dia kasih dua information, 2 dengan 20. So 2 ampere tu simbol apa kita nak tulis? I, very good. 20 seconds tu is your T lah. Dia kata soalan satu dia nak charge flow through the wire during this time. Simbol apa kita nak pakai ni? Kita tanya soalan simbol apa?
Q.
Q, very good. Then yang B tu dia kata numbers of electron passing through the wire during this time. So numbers of electron simbol apa?
NE.
Okay, N, very good. And E boleh kan? N subscript E. Okay, and then C kata numbers of electron per second. So basically it is N over T. Okay, once kamu dah buat macam tu, dia senang je lah. So question A dia kata dia nak Q. Apa relation Q dengan I? Ingat tak? I sama dengan dQ dt kan, untuk instantaneous, tapi sebab ini average lah, jadi Q over T. Apa nak Q, so I darab T, I is 2, T is 20, you should get 40 ampere, sorry 40 coulomb. Okay, soalan B pula, dia kata numbers of electron. So apa relation number of electron with the charge?
Q equal to NE.
Yes, very good. Q equals to NE. So your numbers of electron is N, which is charge divided by the constant 1.6 times 10 negative 19. Apa ni dapat? 42.5 times 10 negative 20. Okay, don't forget to write down the unit, which is number of electron. Okay, and then question C, they want to find numbers of electron per second passing through the wire during this time. Okay, so untuk C, dia nak N over T, N is, sorry, T is 20 20 ke? Okay, 20 second tu. So got here is 1.25 times 10 to the power of 19 electrons per second. Per S lah. Okay, any question? Faham ke tidak?
Faham
Faham,
sir.
sir.
Faham sir.
Right. Saya nak cakap something, saya lupa nak cakap apa. Tak ada benda kot. Okay, unit ada, semua ada. Okay. Kalau tak ada soalan, kita pergi ke soalan seterusnya, which is question number 7. Dia kata an electric conductor has a square cross section with a side 3 mm and its length is 15 meter. The resistance between the ends is 0.072 ohm. So if I want to draw, maybe it look something like this. It's a square. Kamu boleh anggap dia macam wire yang bentuk square. Okay, so dia kasih 3 mm, itu dia punya apa tu? Square cross section punya side. So A dia sama dengan 3 times 10 negative 3 square. So area kamu should be 9 times 10 negative 6. Tak, this one. Okay.
Betul sir.
And then the length 15 meters. So itu dia punya L. The resistance is your R, 0.072 ohm. Okay, the first question they want you to find the resistivity of the material. Resistivity ni simbol apa?
Rho.
Rho. Very good. So kita kira tu terus lah. Rho sama dengan RA over L. So rho sama dengan 0.072. Area is 9 times 10 negative 6. 15 meter. You should get 4.32. And the unit will be ohms meter. Question B, if power supply of 5 volts supplied between the two ends of the wire, determine the current that flows through the resistor. So soalan B ni dia nak apa? Determine the current that flows through the conductor.
Dia nak I.
I, okay, good. So kita ada V sebab dia kasih yang 5 volt kan. So dia kata V sama dengan 5 volt. They ask you to find I can use Ohm's law, where V is equals to IR and I is equals to V over R. 5 divided by 0.072. Got here 69.44. Okay, kau dapat ni cakap And then question C, dia kata if the length of the conductor is decreased, that's what will happen to the resistance in the conductor. So dia kata apa yang decrease?
Length.
Length. Dia kata kalau length decrease, apa jadi dekat R?
Decrease.
Okay. Cara nak jawab dia, okay, I show you in case kamu dapat such questions and they ask you to explain. So when they say explain, you have to give a reasons lah. So the first thing is that you can pick any formula from equation that normally you will like to relate lah between L dengan R. So one equation yang ada L dengan R is rho equals to RA over L. Okay, if rho and A is a constant, then I can say that R is inversely proportional to the length. Therefore, if dia cakap apa, L increase ke decrease? L decrease, okay, saya salah tulis, bukan 1 over L, L, because if you rearrange this one, you can bring the L over there, so R is directly proportional to L. So if L is decreased, and R is decreased. We decrease ke increase ni?
Decrease.
Decrease lah. Okay. So R dia decrease lah. Macam ni? Tiba confused lah. Okay, itu for question C. For question D, so macam tu jawab dia. Normally you would like to take any equation yang kamu rasa relatable. Tu dia je. Kadang-kadang ada markah, kadang-kadang tak ada markah. Biasanya tak ada markah part ni. Tapi tu dia lah. So biasa markah dia dekat sini 1 mark, and then yang bawah ni 1 mark. Ini yang paling penting sebenarnya. And then the last question dia kata, if the conductor is replaced with another conductor that has higher resistivity, explain what will happen to the current. So dia kata, if rho is increased, what happened to the current? Macam mana nak jawab ikut atas tu? Kita buat apa dulu?
Bagi equation dulu.
Yes, from equation kita ada yang kalau melibatkan rho ada satu equation je, rho equals to RA over L, tapi dia tanya pasal current, betul? So kamu kena relatekan dengan dua formula lah. Compare with the values for R first, and then kamu boleh pakai Ohm's law untuk second equation. So here rho is directly proportional to R. If cerita dia rho higher, saya lupa, higher resistivity. So if rho increase, that means your R is increased as well. On the other hand, if I want to relate from equation, sebab soalan ni nak I can relate from equation V equals to IR. Lepas tu relation dia, I is inversely proportional to R. So that means if R increase, I decrease. Okay, clear or not?
Yes.
Okay. Saya balik sikit, napakkan sikit, napakkan sikit. Kalau tak ada soalan, maybe kita boleh moving on to the next one. Next question is question number 8. Okay, yang ni dia kata ada perubahan temperature, you can see the moment dia cakap temperature, you know straight away. At 20 Celsius, the resistor in electric circuit connect to a 5 volt battery has a resistance of 200 ohm. Calculate the new resistance when the temperature of the carbon rises to 80 Celsius and new current flow in the circuit. So they want you to find new resistance R and the current flow in the circuit I. Given information, dia kata at 20 Celsius, so that one is your initial temperature. Resistance is R0, sebab ini yang initial lah, 200 ohm. New temperature is at 80 Celsius, so they want you to find R. And then at the same time it says about V equals to 5 volt. Okay. So if I want to solve this one, I can use R equals to R0 1 minus alpha delta T. Minus ke tambah ni?
Tambah, sir.
Tambah, okay. Masih lupa je. Tambah. So R here is equals to 200 1 plus alpha is given 5 times 10 negative 3. Unit dia tak kisah. Delta T will be T final minus T initial. Saya tulis kat tepi ni delta T sama dengan T minus T naught lah, which is 80 minus 20. Okay, so if you press the calculator, you should get apa ni? 260. Did you get the same answer with me?
Yes, yes.
Okay, good. 260 ohm. So you can see that as the temperature is increased, the resistance also increase. So makes sense lah. Question B, dia kata the new current flow in the circuit. So potential masih lagi sama. So V is equals to IR. We have the same potential, which is 5. We want to find I if R is 260, the new R. So I here will be equals to 5 divided by 260, 0.019219. Okay. Any question?
No question, sir.
Okay, we try to look at one more question. Okay, which is question number 9A. Question number 9B, you can try to do it yourself after this. Okay. You can see that you have to combine a little bit about your knowledge on series and parallel. Okay, series and parallel kita belajar next topik, tapi boleh buat lah, tak ada masalah. Series, parallel, resistance kamu dah belajar sebenarnya kat sekolah. Question 9A, dia kata resistor of 5 ohm connected across a battery of EMF 120 volt, internal resistance of 1. There are a few values, 5 ohm, 1 ohm, 12 volt. Soalan satu kali, the current in the circuit dia nak I, terminal voltage dia nak VT. Okay, yang 5 ohm ni kamu nak pakai simbol apa to represent? Guys, simbol apa nak represent 5 ohms?
R.
R besar, R kecil?
R besar.
R besar.
R besar.
Okay. Kalau R yang satu tu R kecil, and then yang 12 volt tu simbol apa nak represent?
V. VT.
V bukan. Sebab dia kata EMF 12.0 volt, maksudnya EMF tu adalah epsilon. Okay. Lagi satu kamu perasan lah, kalau kamu tengok yang soalan dia ni, dia tanya, dia suruh cari terminal voltage. Terminal voltage is VT. So maksudnya yang tadi tu bukan VT lah yang dekat dalam soalan tu, itu sebenarnya adalah EMF epsilon. Okay, if going back to the theoretical part tadi, saya just nak pergi circuit tu, semalam lagi balik, saya just copy everything, termasuk formula sekali copy, and I'm going to paste it over here. Okay, salah sini. Ayo. Cut this one. Tak mana. Paste it over here. Kecilkan sikit. Okay. Soalan pertama dia nak current in the circuit. Kamu nak pakai equation mana? Atas ke bawah?
Equation atas.
Yes, you can use the top equation. Sikit. Okay, kalau kamu tengok dekat graph ni, tadi equation atas saya tulis jap. Epsilon equals to I R plus R. Okay, dah petang-petang ni saya punya epsilon pun ditentu. Okay, kalau kamu tengok daripada circuits tu, EMF tu actually over here. Saya just tulis kat sini ya. Tak maaf pula. Okay, yang VR tak ada, yang R kecil tu sama dengan 1. Saya nak bikin balik lah. Khawatir. Okay, so yang 12 volt tu is actually your epsilon. Your small r is equals to 1 ohm, and then yang R besar tu is equals to 5 ohm. So dalam exam kamu boleh draw dulu lah, draw and then kamu boleh label ikut accordingly. Okay, the first question kata nak current in the circuit. So biasa student dia akan confuse dekat EMF punya value. So VT dengan 12 tu dia confuse. Lepas tu R besar R kecil tu biasanya okay je. So 6, so I is 12 divided by 6, which is 2 ampere. Okay, that was for A1. A2, they want to find terminal voltage. So kalau A2 nak selesaikan macam mana?
Okay, second formula.
Okay, you can use second formula. Atau second formula boleh juga, ataupun kalau cara lain kamu boleh tahu yang VT tadi, kalau kamu ingat saya ada cakap V terminal ni sama dengan VR. Okay, so you know that VR is equals to IR, sebab satu circuit tu satu je kan current dia. So I can solve this one, 2 multiplied by 5, I should get 10 volt. So if you compare with the EMF, so EMF tu adalah 12 volt. So it makes sense that your V terminal is less daripada 12 volt tu. So far everything that you calculate, it makes sense. So most likely correct, memang correct lah. Memang betul lah. Kalau kamu nak kira yang pakai equation yang second tu pun boleh, saya tunjuk juga. Or epsilon equals to V terminal plus IR. Epsilon sama dengan 12. V terminal kita nak kira. I is 2 multiplied by 1. V terminal equals to 10 volt. Sama je. Okay. Ada soalan ke tidak? Okay, if there's no question.
Sir.
Yes.
So in any situation, VT sama dengan VR lah.
But you have to be careful lah. VR yang kita samakan tu sebenarnya adalah R efektif. Maksudnya R yang satu circuit kita dah kira lah, yang R eksternal tu. So kadang-kadang dikasih dekat sini, kadang-kadang jarang dikasih VR ni ada few, maybe parallel ke. So kamu kena selesaikan ni dulu, and then baru dia boleh pakai R efektif lah.
Faham. Okay.
Jadi R efektif ni. Okay, so if there's no question, kita boleh berhenti dulu for today. Okay, I see you guys tomorrow. Tomorrow kita ada macam biasa lah.